Moving to the vast, sprawling cities seen in Star Wars, like Coruscant, the massive, planet-wide city that serves as the heart of the galaxy's government, we find ourselves wondering if such cities could ever exist. As Earth's population grows, the concept of sprawling megacities is becoming more realistic. Some cities, such as Tokyo, New York, and Shanghai, already span vast areas and have populations in the tens of millions. But a city that covers an entire planet would present significant challenges, including resource management, pollution control, and infrastructure. Building vertically, as seen in the skyscraper-filled landscapes of Star Wars, could be one way to address these challenges, but managing an entire planet of interconnected infrastructure would require advancements in technology and engineering that are still a long way off. However, with current trends in urbanization and sustainable building, a future where we have massive, interconnected city networks across continents isn't entirely out of reach. Star Wars has captured our imaginations for decades, transporting us to a galaxy far, far away where lightsabers hum, starships travel faster than light, and strange forces shape the very fabric of existence. But what if we could peel back the layers of this cinematic universe and examine the science behind these technologies and phenomena? Could the incredible feats portrayed in Star Wars actually be possible, or are they simply a result of creative fiction? Let's explore the physics of Star Wars and see how it stands up to the real world of modern science. Another fascinating aspect of Star Wars technology is the use of holograms for communication. Characters routinely hold conversations with each other through fully three-dimensional projections, allowing them to see and hear each other in real time. While hologram technology exists today, it's still fairly basic, limited mostly to static images or very simplified 3D projections. Live, interactive holography, where a 3D projection of a person can communicate in real time, remains a difficult challenge. Current advancements in augmented reality and virtual reality, however, are getting us closer to immersive experiences. In the future, we may have hologram-like technology that can allow us to communicate more interactively, although the high level of realism seen in Star Wars will likely require further breakthroughs. One of the most iconic and beloved aspects of Star Wars is the lightsaber. This glowing weapon of choice for Jedi and Sith alike is a powerful symbol of the Force, but could it really exist in our universe? The concept of a lightsaber revolves around a blade of pure plasma contained within a magnetic field. Plasma is a superheated, electrically charged gas, and in theory, it could be contained and shaped with the right technology. However, the problem arises when we consider how to generate a blade that's stable, durable, and capable of cutting through almost anything, as lightsabers do. In reality, plasma is extremely difficult to contain in such a small area, and keeping it from dissipating into the air would require an enormous amount of energy. Additionally, the lightsaber's ability to stop at a certain length suggests a level of control over plasma that we simply don't have with current technology. So while the idea of a lightsaber is thrilling, it's unlikely to become a reality anytime soon, at least not in the way it's portrayed in Star Wars. Finally, one of the biggest themes in Star Wars is the idea of space warfare. Starships engaged in epic dogfights, firing lasers and dodging asteroids are central to the series. But could space battles like these happen in reality? Space warfare would present numerous challenges that we don't face in terrestrial combat. First, there's the issue of zero gravity, which would affect how ships move and fire weapons. Traditional projectile-based weaponry could push ships off course, and maintaining stealth would be incredibly difficult in the vast openness of space. Additionally, space warfare would require massive amounts of energy to power ships, shields, and weapons. While we do have some early forms of space-based weaponry, such as missile defense systems, the concept of massive starships engaging in battles across space is still beyond our current capabilities. Then there's the concept of faster-than-light travel, or FTL, which is a staple in Star Wars as starships zip across the galaxy in the blink of an eye using hyperdrive technology. In the movies, this phenomenon allows characters to travel vast distances almost instantaneously, bypassing the limitations of light-speed travel. But what does modern physics say about the possibility of FTL travel? According to Einstein's theory of relativity, nothing can travel faster than the speed of light in a vacuum. This is one of the fundamental principles of modern physics, and it has been tested and confirmed in numerous experiments. So how does Star Wars get around this? The answer lies in the concept of hyperspace, a fictional dimension that allows starships to bypass the normal space-time continuum. Hyperspace travel is a clever workaround for the limitations of light speed, and while it works in the Star Wars universe, there is no scientific basis for hyperspace as we understand it. In the end, Star Wars serves as a fantastical vision of the future, where scientific limitations are pushed aside in favor of adventure, mystery, and epic storytelling. Many of the technologies and phenomena portrayed in Star Wars remain in the realm of science fiction, but they inspire us to dream big and imagine what could be possible if science continues to advance. The line between science and fiction may be thick now, but as we continue to explore, innovate, and push the boundaries of human understanding, who knows what discoveries might bring us closer to the wonders of a galaxy far, far away. Some physicists have speculated about the possibility of wormholes, shortcuts through space-time that could allow for faster-than-light travel, but these remain purely theoretical at this point. Until we find a way to manipulate the fabric of space itself, faster-than-light travel will remain a work of science fiction. But what really fires up the imagination is the concept of hyperspace travel, that dizzying leap through stars where the Millennium Falcon can zip across the galaxy in seconds. Traveling faster than light is a staple of Star Wars, yet it presents one of the biggest physics challenges out there. According to Einstein's theory of relativity, nothing with mass can travel faster than the speed of light without requiring infinite energy, a concept that has long made light speed travel impossible, according to our current understanding. Yet, intriguing theoretical physics concepts like wormholes and warp drives offer a glimmer of hope for achieving interstellar travel. Wormholes, for example, are hypothetical shortcuts through space-time, where space folds on itself to connect two distant points instantly. Imagine it like taking a secret passage across the galaxy. While no wormholes have been proven to exist or be stable, scientists are exploring the possibility, and it's an exciting area of theoretical physics that could one day open doors to hyperspace journeys. Now, let's talk about the Force, one of the most mysterious and central elements in the Star Wars universe. The Force is often described as an energy field that binds all living things together, and those who are sensitive to it can use its power to move objects, influence minds, and even perform feats of extraordinary agility. But can we find any scientific basis for the Force in the real world? The idea of an invisible energy field that connects all life on a deep, fundamental level is certainly intriguing. In physics, we do have something that might loosely resemble the Force, the concept of fields. Gravitational fields, electromagnetic fields, and even quantum fields govern the behavior of particles and forces in the universe. However, the Force as it's depicted in Star Wars is far more than a simple field. It has an almost mystical, spiritual quality that goes beyond what physics can explain. The idea of a warp drive, inspired by science fiction, presents another possibility. A warp drive could theoretically allow a spacecraft to move faster than light by bending space around it, rather than traveling through it. Think of it like riding a wave of space-time itself, pushing and pulling the universe to move the ship. Physicists, including the renowned Dr. Miguel Alcubierre, have even proposed models for such a drive, showing that with an incredible amount of energy, it might be possible to create a warp bubble. Inside this bubble, a ship would remain stationary while the bubble moves through space at superluminal speeds. While current technology is far from achieving such energy levels, scientists and engineers are exploring alternative ways to harness this concept. So while we may not have a hyperdrive today, Star Wars' vision of zipping across the stars is something that theoretical physicists are still intrigued by and are trying to understand. There is no known force or energy in the universe that allows individuals to manipulate objects with their minds or influence other people's thoughts. While certain aspects of the Force, such as telekinesis and mind control, can be explored through the lens of quantum physics or neuroscience, the true nature of the Force remains firmly in the realm of fiction. And then there's the iconic lightsaber, the weapon of choice for Jedi and Sith alike. These glowing energy swords can slice through nearly anything, block laser blasts, and deliver intense heat. But how feasible is it to create a weapon like that with modern science? A lightsaber would need an enormous power source to contain plasma or light energy in a confined space, something small enough to be held in a hilt but powerful enough to create a deadly, glowing blade. Plasma, a state of matter found in stars, might provide a starting point, but creating a stable, weapon-sized plasma blade poses technical challenges. Containing such a blade would require magnetic fields or advanced force field technology tools we haven't yet mastered on such a small scale. Yet scientists are making advances with high-energy lasers and even plasma research that could one day make lightsaber-like technology a reality. Though a real lightsaber remains speculative, ongoing experiments in energy weapons show just how close we're coming to reimagining weaponry in ways that resonate with Star Wars' iconic vision. Another fascinating aspect of Star Wars is the technology and weaponry used by both the Empire and the Rebel Alliance. Take the Death Star, for instance, a moon-sized space station capable of destroying entire planets with a single shot from its super laser. Could such a weapon be possible, given the laws of physics? While the idea of a planet-destroying weapon sounds like something out of a science fiction nightmare, there is a kernel of truth to the concept. In theory, a weapon capable of releasing an enormous amount of energy in a concentrated beam could have the potential to cause massive destruction. Lasers, for example, are a real technology that has been developed and used for a variety of purposes, from communication to military applications. However, the amount of energy required to destroy a planet would be staggering, far beyond the capabilities of current technology. The Death Star's ability to destroy an entire planet with a single shot relies on fictional advancements in energy generation and storage. While we may one day develop weapons of greater power, the destruction of an entire planet would still be beyond our reach for the foreseeable future. Another Star Wars phenomenon that's worth examining is the concept of artificial gravity. In the Star Wars universe, gravity is somehow generated within starships, space stations, and even on planets that lack sufficient mass to produce it naturally. While artificial gravity makes for a great cinematic effect, the reality is far more complicated. In space, there is no natural gravity unless an object is large enough to generate it, like a planet or star. So, how do we create gravity in a spaceship? Currently, the most feasible method is through centrifugal force, where a rotating object creates the sensation of gravity by pushing objects toward the outer walls. This is similar to the way water in a spinning bucket is pushed outward. However, the technology required to generate true artificial gravity, like what we see in Star Wars, would be a major scientific breakthrough, one that would require a deeper understanding of physics and energy manipulation. Until that happens, we'll have to stick with the centrifugal force method for creating gravity in space. Let's also consider the role of the Force, a mystical energy field binding all life in Star Wars. Though the Force itself remains purely fictional, it opens up fascinating questions about consciousness, energy, and the unknown connections in our universe. While we may not have Jedi powers, science is making strides in understanding human perception, consciousness, and even mind control to some degree. Research in fields like quantum mechanics and neurology has sparked curiosity about phenomena like quantum entanglement, where particles are mysteriously connected across distances, which some see as echoing the Force's interconnectedness. Additionally, developments in brain-machine interfaces suggest that one day we might control devices with thought alone, if not with a Jedi mind trick, then certainly with a brainwave-controlled gesture. Although the Force remains science fiction, our understanding of consciousness and quantum phenomena keeps advancing, sparking new theories and studies into the mind's potential and our place in the cosmos. And let's not forget the iconic blasters used by both the Empire and the Rebel Alliance. These weapons fire bolts of energy capable of stunning or vaporizing their targets. In reality, energy weapons like this do exist, but they are far less powerful and practical than what's shown in Star Wars. Laser weapons or directed energy weapons have been in development for years, and there have been several successful tests of these systems. However, the power needed to create the kind of blaster bolts seen in Star Wars would require an immense amount of energy, far more than current technology can produce in such a compact form. Moreover, the precision and targeting systems needed for such weapons would require significant advancements in optics, energy storage, and control systems. When we examine the sheer scope of Star Wars galactic politics, it mirrors issues we face today on a planetary level. In Star Wars, the Galactic Republic and the Empire represent polar opposite visions of order and freedom. The idea of galactic governance challenges us to think about what might happen if Earth ever joined a broader cosmic community. Could humanity find a way to govern itself fairly among other intelligent species, or would conflicts mirror those in Star Wars? Current global politics hint at the difficulties we might face: border disputes, resource allocation, ideological differences, and questions of autonomy. Just as Star Wars raises questions about freedom, control, and unity on a galactic scale, the growing field of space law and treaties aims to set foundational rules for peaceful exploration and potential colonization of other planets. The groundwork we lay today in space ethics and governance could one day help us manage relations on a larger interstellar scale. And of course, one of the biggest draws of Star Wars is the fantasy of visiting diverse planets, from the desert landscapes of Tatooine to the lush forests of Endor. The idea of exploring and inhabiting different worlds isn't just fantasy, it's a growing possibility with Mars exploration and exoplanet studies. With space agencies actively planning missions to Mars and scientists finding potentially habitable exoplanets, Star Wars gives us a glimpse of what interplanetary exploration might look like. Today, we're taking steps to make other planets habitable with experiments in growing food in space and developing sustainable life support systems. It's a slow and costly process, but as we inch closer to Mars missions, the dream of living on another world feels less like science fiction and more like an achievable future. As we analyze these elements of Star Wars through the lens of modern physics, it becomes clear that while the franchise is filled with captivating ideas and technologies, much of what we see is based in pure fiction. That doesn't mean the future won't hold amazing scientific breakthroughs that could make some of these concepts a reality, but for now, they remain firmly in the realm of imagination. And that's part of the magic of Star Wars. It's a universe that allows us to dream big and wonder what could be possible. So while we may not have lightsabers or hyperdrives yet, we can still marvel at the creativity and wonder that the Star Wars universe inspires, knowing that science may one day catch up to fiction in ways we can't even imagine. In this way, Star Wars blends imagination with themes that inspire real scientific progress and spark innovation. Technologies and ideas that once seemed fantastical now fall within the scope of possibility, pushing us to question our limits and consider what's achievable. Although Star Wars takes creative liberties with science, it serves as a cultural landmark that propels curiosity and ambition. The future may not look exactly like a galaxy far, far away, but it's exciting to think that we're inching closer to realizing aspects of this fictional world, motivated by a franchise that dared us to dream beyond the stars. Star Wars is filled with incredible worlds, technologies, and beings that capture our imaginations and take us on journeys through space, but there's something so captivating about digging deeper and wondering, could any of this actually work? When we dive into the realms of possibility, it's fascinating to see how close or how far we are from some of the universe's most iconic features. Take, for example, the concept of cloning, which in Star Wars led to the creation of an entire clone army. In the movies, cloning seems almost straightforward: create an army by replicating a soldier and simply training them up to be ready for battle. But could we replicate a human being in real life like that? Today, cloning is scientifically possible, and it has already been done with animals. Dolly the sheep, famously cloned in 1996, was one of the first major breakthroughs in the field. Since then, scientists have cloned other animals, and there is ongoing research into cloning human cells. However, cloning an entire human being with the precision and speed seen in Star Wars remains firmly in the realm of science fiction. As we continue to push the boundaries of science, one thing becomes clear: while Star Wars might not be scientifically accurate down to every last detail, its impact on our dreams, goals, and imagination is undeniable. From lightsabers to hyperdrives, the technologies that once seemed impossible now lie within the realm of scientific inquiry and exploration. What's most captivating is how these ideas spark real-world advancements, encouraging generations of scientists, engineers, and dreamers to turn fiction into reality. For starters, cloning a human is incredibly complex, and there are vast ethical considerations that make it even more challenging. Scientists would need to replicate not only the genetic material but also the environment, training, and education to create a clone army like in Star Wars. And let's not forget the potential consequences of such a feat. Who would these clones be loyal to? Would they have individual personalities, or would they simply be mindless soldiers? In reality, human cloning presents more questions than answers. Even if it were possible, there are massive societal, ethical, and moral implications that could make a real-life clone army an unlikely endeavor. So, will we ever reach a future like Star Wars? Perhaps not exactly. We may never wield lightsabers or hear the hum of a hyperdrive, but by pursuing the questions that these ideas raise, we expand the very limits of human potential. Every breakthrough brings us closer to discovering the wonders that await beyond Earth's orbit. In the end, the beauty of Star Wars lies in its ability to remind us that the universe is vast, mysterious, and full of possibility, a place where the line between science and fiction blurs, and where every impossible idea might just be a new frontier waiting to be explored. Then there's the incredible diversity of alien species that Star Wars showcases. From the wise Yoda to the mischievous Ewoks, the galaxy is full of beings that range wildly in size, shape, and ability. But how likely is it that we'll find life elsewhere in the universe, and could it be as diverse as what we see in Star Wars? Scientists are actively searching for signs of life on other planets, especially within our own solar system on moons like Europa and Enceladus, where liquid water is believed to exist. But for now, we have not found any definitive signs of life. If we do, there's a chance it may be microbial or simple in form, given the harsh environments of many other planets. That said, if we look beyond our solar system to the vast number of exoplanets in our galaxy, the chances of finding diverse life increase dramatically. Some scientists even argue that given the sheer number of stars and planets, it would be surprising if life didn't exist elsewhere. However, whether that life would resemble the fantastical creatures in Star Wars is another question entirely. Evolution would likely take different paths on different planets, leading to forms we can't even imagine. May the curiosity, the wonder, and the journey continue. One of the more mysterious aspects of Star Wars is the concept of droids, which are essentially intelligent robots with personalities, preferences, and, at times, emotions. C-3PO and R2-D2 are iconic examples, serving as both helpful companions and comic relief. In reality, artificial intelligence has made incredible strides in recent years, with machines becoming more intelligent, learning from data, and even simulating certain aspects of human interaction. But could AI ever evolve to the point of becoming as sentient and personable as these droids? Current AI technology can perform specialized tasks and even hold conversations, but it's still far from true consciousness. True AI sentience, where a machine can genuinely experience emotions, form opinions, or develop a sense of self, is a major area of debate among scientists and ethicists. We may one day reach a level of advanced AI where machines can mimic human-like responses so convincingly that they seem almost alive. But for now, the closest we get to a sentient droid is something like a virtual assistant that can respond to questions or predict what we want based on previous interactions,